Thank you all for joining us today. We're really excited about the talk we have planned. My name is Lauren Reed. I am a Building Decarbonization Manager at RMI, and I actually just recently moved back to Madison, so I'm excited to be in town with you all today. And I am joined by three fabulous panelists, Tyson Cook, Robin Lazeski, and Jacob Foytz. Like I said, today we're going to talk about energy resiliency in Wisconsin. That is a topic that has been front of mind for a lot of people, but it also has a different definition for a lot of people, and it shows up in a lot of different ways across the climate economy and the climate sector and the energy sector. So we're going to get into some of those questions today. What is energy and climate resiliency and adaptation? What are some of the solutions out there that people are pursuing? And what are some inspiring projects that we see today? So we're going to start with introducing each of our panelists and hearing a little bit from them. So I'll have each of our panelists start by sharing their name, their position, kind of what they do in their job. And then let's start with the basic questions like, what is energy resiliency and adaptation to you, and how does it show up in your work? So we'll start with you, Tyson.
Great. So my name is Tyson Cook. I'm the Senior Manager for Customer Generation Resources at Alliant Energy. So in my role there, I'm responsible for strategy and execution around all of our distributed energy resource programs, customer generation offerings. That's ranges from kind of the rooftop solar interconnection services and dealing with independent power producers, but then also to our community solar and what we call our Renewable Energy Partners program, which is kind of a larger scale, kind of one-off clean energy program, and just a whole range of things that generally revolve around providing more access to clean energy for customers that want that, both in Iowa and Wisconsin. So in terms of the question, what does resiliency mean to me? Hazard of the trade, I think about it a little bit from an engineering perspective. And when I think about resiliency, it's about how do systems and processes adapt to pressures and disruptions. And so you all have probably heard, and I happen to agree with this idea that the electrical distribution system is the single largest and most complex machine that we've ever built or operated. And at the end of the day, resilience for me is, again, what happens when there's disruptions to the machine or to the system. There's this concept called graceful failure. And so if you haven't heard graceful failure, it's not about looking cool when you trip, right? It's about what happens when there's those disruptions, and do you have a system or a machine that's resilient to that? The classic example being an escalator, right? When an escalator breaks, it becomes stairs. It still works, right? That's graceful failure. It's about when something happens, when there's a breakage or a disruption, is it catastrophic? Like, oh my goodness, this doesn't work anymore. I wish I had learned to build a fire without matches kind of failure? Or is it okay, I guess I have to take the stairs. Oh wait, this still is stairs kind of failure. And so when we designed the generation side of the grid, we actually really kind of take that into consideration. We have multiple layers of redundancy. We have what we call planning reserve margin requirements, right? One electrical power plant going out does not stop you from having electricity. It happens all the time. You wouldn't even know. Unfortunately, on the distribution side, we're not quite so resilient, right? The distribution system tends to be largely radial or linear. You have like one power line that's going to an area, and it's binary. Your power is either on, it's working, or it's off. That's broken.
A squirrel can take you out.
Yeah, exactly, right? So when I think about resilience, it's really about things like that. You've got a system where you can be disrupted by a squirrel or a tree branch or a traffic accident or other sorts of weather, and that causes catastrophic, doesn't explode things usually, but the service stops working entirely because of that one disruption. that's not very resilient. And so for me, it really comes down to this question of what do we do? How do we react to pressures? And how can we adapt our system to be better at providing some level of service even when there's disruptions?
Awesome. Thank you so much, Tyson. Robin, I'll hand it to you.
Sure. I'm Robin Lasewski. Good afternoon, everybody. I work for Slipstream. We are a C3 nonprofit headquartered in Madison. Celebrated our 45th birthday last year, so we've been around for a while. I'm the policy director there. Slipstream does research primarily in the building sector and building decarbonization work that informs programs that we design and implement. We do some financing to overcome the first cost barriers of largely residential, but also some small commercial programs. Policy work is the area that I lead, and then also workforce training, because the heat pumps are not going to install themselves, as I often like to joke. I generally use a pretty traditional mitigation versus like resiliency or adaptation kind of definition of resiliency, and that simply being that if there is something catastrophic that happens, are you able to bounce back from that experience at whatever scale? That might be at the household level or at a system level or a utility level. And then I think Tyson gave a much more elegant a description of his imagination of resiliency. Largely agree. I use maybe just a simpler one.
Thank you, Robin. Jacob?
Yeah. Hello, everybody. My name is Jacob Foytz. I am with FTI. Might not have heard of them. FTI is a lot of things, specifically as it pertains to energy. We're an EPC contractor, so build out turnkey solutions in really any form of energy. Solar, storage, wind, have been the popular ones. Lots of folks are taking renewed looks at things like natural gas fuel cells, hydrogen, and traditional reciprocating generation. I spend the majority of my time in early stage development with our customers and prospective customers, understanding what their energy goals are from a sustainability standpoint, from a cost standpoint, from a resiliency standpoint, and then helping navigate them to the right solution, because there are a lot of options in the market right now and new ones coming out every day. So, spend a lot of my time just keeping up on technology and market conditions and pricing and the like. So that certainly colors my my answer, and you guys stole the good answer, so I'm gonna have to come up with something new. But when I think about resiliency lately, I've been thinking a lot about cost resiliency. It's great if your power's on, but if you can't afford it because it's gotten so expensive due to some weather event or some geopolitical conflict, we've seen natural gas prices do obscene things in the last couple days, and so as small residential consumers, obviously we're kind of protected from a lot of those swings up and down, but then we absorb it in the long run as those costs that are absorbed initially by the utility companies are then passed down to consumers. And that's everything that people are talking about in energy right now, and our ability to be resilient to that. We work primarily with businesses and larger enterprises. And as we propose energy projects, we're seeing folks take a lot bigger look and put a lot more weight on what sort of resiliency that type of project could give them towards fluctuations in energy prices in the future, right? The punchline being, if you own the asset, if you're self-generating or you have a long-term contract to take the energy from some asset, you're cushioning yourself a lot from what might happen with energy prices. And it was I think probably the main thing they were talking about in the last session. Data centers and energy growth, energy load in general, it's going to drive prices up, right? Even if tomorrow every single data center provided all of their own generation and didn't connect to the grid, they're going to be using a lot of natural gas. That's going to drive the price of natural gas up. They're going to be using a lot of equipment that utilities would otherwise connected to the grid. And the punchline is that if demand goes up, whether it's connected to the grid or not, the cost is going to go up. And so I think a lot about, and our customers are thinking a lot about how they can be resilient against that cost pressure that's coming. So that's my unique answer. You had the right one, though. So.
Thank you all three. As you can all see, the energy resiliency has a lot of different definitions, and it comes up in the work that we all do in different ways. And so really excited to have these different perspectives. We got a couple questions planned out that we will be talking through, but if at any point any of you have a question, like a follow-up question or an entirely new question that you want to throw at the panel, just raise up your hand. I'll be keeping an eye on all of you and we can get that answered. But please feel free to do that when the mood strikes you. So my next question for this panel, I'm going to start with you, Robin. You just previewed a little bit of conversation around the work you do in the building space, in residential and commercial resiliency, and I know that you have a particular focus on policy and program administration is something I know Slipstream does a lot of. So I'm curious to hear a little bit deeper of where do you see some of the biggest energy resilience vulnerabilities in the building space, and where are you seeing policies rise up to meet that problem?
Yeah, I think some of the biggest vulnerabilities are when there is an outage at a utility level, who is left behind, and which neighborhoods get cut off first and are restored latest. So that is an area of mission concern for Slipstream for sure. And always with that as the backdrop or the foundation for our thinking, and in our focus of building sector work in particular, I think there are some pretty 101 things that we can be doing in building installations with equipment in there. Raising the heat pump, if you're installing a heat pump, to raise it so it's not flooded when there is a flood, which Wisconsin is expected to experience, or shielding it from snow for the snow and sleet that we get, and taking preparations like that. And inadequate weatherization. I think sometimes we forget the most basic facts of the measures that we have at our disposal for energy efficiency. So a well-weatherized, air-sealed home is thermal storage. And so when we are not well-weatherized, we don't have that advantage of staying warm when it's cold outside, or cool when it's warm outside. It is an opportunity to increase our resiliency by focusing on basic energy efficiency, things like weatherization.
Awesome. Thank you, Robin. Tyson, I wanted to circle back to what I heard you talking about on some of the grid issues that states may or may not be facing. And something that I heard from you just now is that there's supply side and demand side. And the demand side is where you're seeing a lot of vulnerabilities. So I invite you to speak a little bit more on some of those vulnerabilities and some innovative strategies that technologies or policies that are being implemented in order to address those concerns.
Yeah, happy to. And that's exactly right. From my perspective, obviously there are vulnerabilities and there are pressures on the supply side, and on the generation side as well. It got a lot louder when I looked that way. This microphone, right? And so that's real. And fuel constraints, fuel supply can be stressed, especially when it's you get a cold snap and everybody's trying to turn on their heat, and the natural gas power plant is also trying to use a lot more natural gas than any given house, obviously. But at the end of the day, we do have sufficient generation, and we have those backups and those redundancies. And so, again, going back to what we were saying about a squirrel, right, or a weather event, when you have that kind of, I would call that a sensitivity in the system, where some kind of minor impact can cause such a major disruption, at the end of the day, it's the distribution system that has the failures that cause power outages more often than not, whether it's weather related or, it semi runs into a transmission pole. I guess that's transmission, but same idea. That's where I see a lot of the vulnerabilities. And interestingly, as we're looking into the future, I think there's more and more technologies that can help address that, right? Electricity's, you all know, you live it every day. It's more and more important for our daily life, whether it's heating and cooling or the economy or travel or what have you. And as it gets more important, the reliability and I think the resiliency becomes that much more important at the same time. And when you have a very centralized system and you're distributing on these kind of radial single lines, you can't ever get to 100%. Now, is 100% the goal? I don't know. It'd probably be very expensive, right, to have 100% resiliency or reliability for everybody. But we can get a lot closer. And things like battery storage systems can make a big difference. We've got a project up in Boaz. It's a small community up in Richland County where it's about, I want to say 200 people live in the village. And it's at the very end of one distribution line. And they've had a lot of problems with outages caused by weather and other events. Alliant installed a relatively small battery storage system there. 400 kilowatts, 8-hour battery, and that lets that community ride through some of the outages that they've been seeing and facing. Now, it's new. It's the first time we've done it. It's a pilot. I'm going to be totally transparent. It's not going perfect. There are still issues, but we're working through them. And that's the kind of solution I think that, again, doesn't get you to 100%. A derecho or a tornado coming through is still going to knock out power for more than 8 hours, but it's really improving that. And I think you can scale that as a solution. You can do it on an individual customer basis, right? So a business or a homeowner can install a battery to help them ride through, or a generator. But you can also look a little bit more system-wide and have these kind of solutions that serve kind of a region also.
Awesome.
Can I add something to that?
Please do.
So I love that example, and using battery energy storage. We've done a few of those types of projects, help mitigate demands. I think that was the initial comment you made, the resiliency within the demand that's there. I think there's so much we can do from an education standpoint as well. The number of times I have conversations with customers and have to explain the concept of a coincident peak. Right, and it's a very complicated thing, and getting somebody to understand that it's not just what you use, it's whatever the rest of the grid is going to do, and it might not be a big deal for you to reduce your demand during a coincident peak, but that's going to have a huge positive impact on on what you're paying and the rest of the grid, and just I think as electricity gets as we kind of run into that demand versus supply constraint, we're going to see, we're going to find it necessary to use a lot more of these tools, educate people. I'm looking at switching over my residents to a time of use rate. My wife got an electric car and my electric bill went up a little bit. And it's got I could make that work, right? And can I save some money? And I just think, point being, battery energy systems, it's great. We need a lot more of that. We're building that. But there's an opportunity for some of the basic stuff in the toolbox is not being fully utilized yet too.
No, totally agree. And the weatherization and those sort of things too can make a big difference. Like you said, thermal mass, thermal storage inside a building. We can trigger more like demand response hours and turn down your Nest thermostat or what have you if you're better weatherized. If you're living in a home or an apartment that's very leaky and, your utility says, hey, we're having an urgent issue. We're going to try to reduce thermostats and it all of a sudden gets really cold in your apartment or your house. You're going to go turn it right back up. Right. And that's, always part of the program is you can always override that. And so it's less effective. But weatherization, energy efficiency, those sort of things really help with that. And, there's like the hardware solutions, right? Like the batteries that we can work on. And if they're correctly designed and implemented, they can make a huge difference. And then there's, the education piece and signals that we as a utility can provide. Time of use rates is a great example. Historically, in Wisconsin, they've been like 12-hour on peak, off peak. Mm-hmm. And that doesn't really help with that coincident, right? We're working to tighten those up and make them more effective going forward.
We've got a question on the audience.
Yeah, we had a question over here, sir.
So you started touching on what my question was going to be. So you've got the fragility of the distribution system. And so my question is, and Boaz sounds like you're doing a little bit of a microgrid situation.
Yep.
And so I'm wondering about the possibility of microgrids in multifamily housing units. And and I have questions in regards to after and before the box types of batteries. If people were putting in lots of Tesla Powerwalls or Generac batteries, Does your system allow for adaptation and use of those kinds of things at this point in time, or is that stuff sort of all pipe dreams for the future, or maybe not something that somebody from the electric utility wants to dream about because it might decrease their ability to charge for peak rates?
It's a great question. It does allow for that. So I think I mentioned at the outset, part of my team is what we call interconnection services. So anytime somebody wants to hook up rooftop solar or a battery or a generator to the grid, they come to us and we make sure that it's done safely, right? And we are seeing more and more people install batteries at their place of residence or their business. It's something that was really expensive 10 years ago. It's still quite expensive, but it's getting cheaper and cheaper. And it's absolutely helping with those individual homes and businesses, their ride-through capabilities. I think the bigger question, at least from my perspective, is how we start to expand that out to have benefits that are broader than just, frankly, the one person who can afford it, because they aren't cheap. And, how much is your temporary outage worth to you? Well, if you can't spend $15,000 on a Tesla Powerwall, it doesn't matter, right? You're going to have to find something else to do. But we are actively working and thinking about how we can bring those types of technologies into a broader solution. We're rolling out, for example, we call it Smart Hours, is our telling people to reduce demand and turn down their thermostats program. We are working to integrate residential energy storage into that. So we can provide incentive to people when the system peak is happening and we need to shut down a little bit or try to tamp down on power demand. We can send a signal out and tell people, hey, turn on your batteries, right? Let's reduce your load on site so that it helps everybody. But yeah, great question, and definitely something that we're seeing more and more of.
And sorry, you're going to say a lot of things I want to add on to. So I think you're asking, complex programs, integrating, pull energy, push energy, all those kind of things. We did a pilot with one of our microgrids with a utility company on giving them access to the batteries and be able to send commands and push energy. It was great, proof of concept and technology and all that. But it can be as simple as cost signals, right? Your smart hours thing. That's, you don't have to be able to go and directly control somebody's thermostat and power wall. If you just put a tariff in front of them and said, hey, this is what the prices are going to look like. Most of these, the Nest systems and all that, they can download those tariffs and incorporate them and act responsibly or accordingly. And so a lot of times that price trigger can be all that it takes to initiate that sort of complex behavior.
Yeah.
About the batteries backing up the grid from homeowners. There's also the potential. A lot of us have electric vehicles that have very large batteries in them. And this vehicle to home thing, it's out there, but it's not an easy thing to do.
Yeah.
It's very difficult and it's very expensive. But I think that, I would certainly plug my car in if I got a text from Alliance said we need help, plug it in. I wouldn't have any problem doing that. So I think I just think we're not really looking at that very carefully. I think that's another potential.
Yeah, absolutely. And that's something that, we've been talking about, frankly, for a long time. We've gotten to the point where we now call it vehicle to X, right? Or X to grid or X to X. But, using the batteries and the technologies that are out there to help power other things. We actually have a pilot program that we're working on with the Cedar Rapids School District in Iowa, where they've got some electric buses, and we're working to get those set up so they can backflow. But you're exactly right that it's not easy. And it's not easy because technologically, electricity is generally designed to flow one way through our distribution system, and that's from the power plants to the houses. And so when I talk about interconnection, it's about making sure that we have everything right and in place, and that just being frank here, that vehicle to grid pilot with the Cedar Rapids School District is another one where it's the first time we're trying it. And it's going slower than we wanted to because the initial chargers that we tried to get in place didn't meet our safety requirements and they weren't capable of doing the bidirectional flow that we wanted. So yes, I think that's coming. I think it's something that we've got an eye on. I think it's a huge potential. The more cars we get out there with batteries, the more storage we're going to have. And there's a lot of opportunity there, but it's going to take some time to get there.
Another question.
Can I ask just a follow-up question on that? So given all the benefits that distributed batteries can have to the grid, and we're talking about all the opportunities in the future that, will be unlocked. What's Alliant doing right now to make it easier to interconnect batteries, to make it more affordable, to make it faster, and to incentivize that rollout so you can really take advantage of all the people out there who want to do the right thing and can support the grid in that endeavor as well?
Yeah, great question, and I'll pay you after the show. So interconnection, it's really complicated, and I'm not going to get into all the hairy details of it, but at the end of the day, anytime you want to connect something that's going to provide electricity, I'm going to call it the wrong direction, not because I don't like it, but because that's not initially how the system was designed. So if you're trying to send electricity and it has the possibility of going from something out to the grid, there's a lot of work that we need to do to make sure that that's done safely and it's not going to cause disruptions to your neighbors. And there's a whole process. And the process has these rules that are required by the state, Chapter PSC 119. What we've been doing at Alliant, and especially over the last, I'll call it 5-10 years, as we've seen rooftop solar and we call them interconnection requests, applications coming in, really just going through the roof. We undertook a pretty big process. I dubbed it internally Interconnection 2.0. And what we did is we looked at it and we said, look, right now it's taking us 60 days. This was about 3 years ago. It takes us 60 days worth of work to analyze an application and send back for more information and then look at it this way. And then it has to go to this team and they got to look at this part. And then this team's got to look at this part. And that's not functional when you're dealing with thousands of these a year. And so we reached out, we talked with installers, and we did a bunch of process analysis. We set a goal of going from 60 down to 6, which maybe it was a little bit too ambitious. We didn't quite meet it, but we got down to 16 days on average. And we'll see in the future how necessary that will have been, because you all know tax credits going away. Rooftop solar installations are probably going to be dropping off quite a bit now. But I will say it was huge for us this last year when all of a sudden we had application volume double, right? And everybody wanted to be connected before December 31st. And so we kind of pulled out all the stops to get that done so people get their tax credits. And now we've got those systems in place. I think it's going to pay dividends. Hopefully application volume comes back up to what it was eventually, but probably not next year.
Thanks, Tyson. We have actually a question on the Q&A. So also if you don't want to raise your hand, you can put it in the Q&A in the app. And I wanted to throw this question out. I thought it was interesting. And I'll start with you, Robin, but if anyone else wants to reply, do so as well. So in the drive for, quote, electrify everything from buildings to transportation, et cetera, how do we affordably and equitably implement resilience? Is it the role of efficiency and weatherization? Is there a role for grid and demand response? How do we do that?
Yeah, I think efficiency still in 2026 is the lowest cost resource. I think it's a mindset about that and we should be thinking about it as generation and unleash and unlock all of the potential that we have before the more expensive options. Tyson's already, we've all kind of talked about this a little bit already, but there's then alongside or closely behind unlocking all of that energy efficiency potential, there's so much we can do with rates that can be equitable rates. And we barely touched rate design in the state and dealt with demand response or responsive demand, things like aggregating efficiency, all of the things that can contribute, particularly in light of the data centers that are coming, not to repeat the session that we're all just walking in here from, but in light of all of that large load coming on, I'm hopeful that we're lighting a bit of fire under the potential that we have with energy efficiency and treating demand response in more elaborate and expansive and rolled out ways, and that can manage price for people in low and moderate income homes and everyone.
Yeah, I'll add, the question listed a few different ideas. Yeah, all of those, and then everything else as well, right? I mean, that's what it's going to take to any amount of additional electrification. That's happening. Obviously, data center stuff, increased demand, and in our development work that we do for customers, one of the first things that we're going to do, because we work across the nation, is we're going to pull the tariff, the electric tariff, the gas tariff, whatever, that they have. And an interesting observation we've made in the past is that the more complex the tariff is, the more likely that we're going to be able to find a solution for that customer that pencils, right? The more options that we're given, the more different time of use rates, demand levels, the more complexity there is there, the more that behind the meter generation, battery energy storage, conservation methods, turning off certain lines during a coincident peak, all of those things make it more advantageous. So, understand the natural urge to keep things simple. We do have very, relatively speaking, simple tariffs in Wisconsin from what we've seen. But I think there can be a lot of advantages in making those more complex and giving customers more options to participate in those types of programs.
Yeah, it might be worth saying more specifically for like low and moderate income households that like a heat pump rate, so that they, or PIP, the percentage of income payment on an energy bill are ways to keep electrification possible.
For years, people have not cared about their utility bill other than like, oh, why is it high now? And it's getting up to the point for folks where they're raising their hands and saying, what can I do? Give me something, give me options, give me a lever that I can pull, because this is getting too painful. And it's just going to keep going in that direction.
Yeah, I appreciate that. And for those who are curious to learn more, there's actually a growing and a body of research on those heat pump rates Robin was speaking to, and how the baseline economics of utility rates actually disincentivize heat pump installations. And so there's a decent body of research if one is to be interested. Yes?
I'm thinking residential scale. What's the contribution to cooking fuel choice? I'm a big fan of induction cooking for lots of reasons. But if the power goes out, it's a lot of bean soup on a wood stove. But can you talk to the benefits of induction cooking and how that fits in the resilience and electrification scene, and how we can make it easier for folks to transition? Someone said today, if you can nail the transition from gas for cooking, you can get the rest of the gas out of the house.
Yeah, I've heard same. Have not heard the cooking framed in a resiliency conversation before. It's usually the internal air quality, or your household air quality with cooking, because of all the pollutant that is released from cooking with gas in the home. Resiliency wise, I don't know, help me out.
Yeah, I'm a bit of a food snob, so I'm all about the induction cooking. I think it is, I upgraded my natural gas to induction. As far as resiliency is concerned, I'm gonna go back to, I'm gonna keep harping this point, but is cost, right? Our grid is extremely reliable still. And so, yeah, your power goes out, you got to make some amends. You're having, ham sandwiches instead of steak dinners for a couple days. Your refrigeration is probably a bigger concern to you at that point than, being able to cook something. And so I think that decision is going to come down to, for a lot of people, is going to be that cost makeup, right? What does it cost me to first purchase and then run? Most induction cooking hardware is still quite expensive. It's on the higher end. So giving people access to that, but
The single hot plate's not.
correct.
The Lonnies are awesome.
Yeah, that's what I have. I won't go down that path. We'll still spend the rest of the day talking about my nerdy cooking gadgets. But more, looking at, if the price of electricity goes up, the natural gas price, and I think folks are going to be looking at that sort of stuff. And if it's going to affect their monthly bill, it's gonna weigh on their decisive factor there. So.
Yeah, and maybe I'll branch out a little bit beyond cooking, although it's a great example. And yes, induction's really cool, but also very expensive if you're trying to replace your range.
Somewhat more expensive. That's part of the myth.
Yeah.
Okay, stand corrected. Thank you. it is more efficient also, right? And so if you have the traditional electric range going to induction, maybe it pays for itself over time. And similar, I would say, for things like transportation electrification, right? Part of the challenge is it's that upfront cost. And will it pay back for itself over time? Yes, probably. But it can be more expensive upfront. And so some of it, I think, comes down to how do we put the systems in place and the incentives in place to assist people getting over that initial kind of adoption hurdle. And some of it is frankly going to happen naturally over time, because as you get more used vehicles on the market and depreciation on EVs, I own one, I'm seeing it. It is not worth nearly how much I still owe on it, but that's fine because my wife loves it. Once that goes up on the used market, eventually it's going to be a lot cheaper, and that's going to help with some of those things. But at the end of the day, the other piece there is the education around you can get on a time of use rate and make it even cheaper to charge at night. And yes, your electricity bill went up, but you used to spend $200 a month on gasoline, and now you're spending $100 on electricity. So your total energy bill has gone down quite a bit, but it's sometimes hard to make that connection. So I think there's an education piece there as well. Like maybe I need to be educated on the price of induction ranges.
This isn't directly related to resiliency, but in May, a bunch of like apartment size induction product is supposed to be dropping. So there are more options. I've always got the other households in mind. And so there's supposed to be a new wave of options. There's a little higher price point than what you would see like an apartment size gas range at, but more affordable. You can see them coming down and just sized for the for multifamily units or smaller units. So we're watching the market evolve.
Yeah. I mean, and there's also a justified, a lot of rental units are on electric resistance stove heating, and removes the conversation of whether you're talking about gas is all electric, but are inefficient, slow, are more expensive to at least operate. And as a person who has only lived in rental properties my whole life, that's certainly a thing I have, operated with for a lot of time. And so, that it's also another solution for that. I saw a hand right here.
I'd like to bring up sort of a different side of the situation. So we had a major storm about 10 days ago. I live in Louisville. We got 11 inches of snow, but south of me in Nashville, it was an ice storm. And they had, as I understand it, enormous disasters with all kinds of tree limbs falling on electric wires. And they had no electricity for at least 10 days. And that caused a lot of human suffering. I'd be interested in ideas on how can that kind of human suffering be avoided with better climate resilience.
I can put a personal touch on it to begin with. Yeah. A coworker of mine is in Nashville. He's still without power. I feel especially bad from him because he was just coming back to work this week from his first daughter being born. His wife and his daughter ended up having to, I don't want to make it sound too dramatic, but flee Nashville. They went down to Birmingham to stay with her parents because you don't want a newborn without electricity. His solution for it was getting a generator and being able to provide power, keep his home warm that way. Luckily he works for an electrical contractor, and they were able to help him figure out how to get that connected in. Behind the meter assets, distributed generation is always going to help with that sort of thing. He lives in a relatively small community, or not small community, but like a small lot size, right? And so lots of trees because everybody loves their trees, but overhead power lines. The cost nationwide of burying all of our overhead power lines is not something anybody's open to taking on from a cost standpoint right now.
Eventually, it will be cheaper than all of this.
It is, but like we talked about in the other topics, there's eventually something pays for itself, but you got to come up with that upfront capital. Somebody's got to foot that bill to begin with, and it's a very large bill to get to the point where you're resilient against things like that. And so in the interim, what individuals can do, individual companies, individual users, is distributed assets, and that's easy at a commercial scale. It's difficult to have those types of assets that you can operate, that continue to work when the grid goes down. Your rooftop solar doesn't do anything. Your typical rooftop solar doesn't do anything when the grid goes down. So I think we'll see more. I mean, you're seeing it starting to come out in consumer level products of devices that are able to operate independent of the grid, but still, be connected to the grid and offer those services as well. They're still, kind of prosumer level products, as they call. They're, expensive products. But as that technology matures and develops, hopefully that, scales down to be available to a lot more people. And I think, just to tie it back again, if you give folks ways to earn money on those assets when the grid is connected, it can really help defray the cost of having to put those in the first place and have them there for resiliency purposes.
Yeah, so first I got to give a shout out to all the line technicians and the engineers that they do just amazing work trying to get power back online. And we have programs nationwide, region-wide, where we provide mutual aid and assistance. So, when these storms happen down south, our people, Alliance people, are leaving their lives and their families, and they're going for days, sometimes weeks at end, to try to restore power. The coolest thing where we're just like, there's agreement between all of these companies across the country that hey, if you have a problem, we'll send our people to help you out. I just think that's amazing. And the fact that we need that is also a little bit amazing. Yes, it's, like I said, the most complicated and largest system ever designed, but it is a system right now that has fragility and it has vulnerabilities and brittleness built in. And so I do think about distributed energy resources. Yes, on the individual family basis, but also more community basis. Like I said, with the One Pilot program and BOAS, if you can think about something that and expand that more broadly, you're bringing some of those benefits kind of to a larger region. Definitely clean energy can provide power, which is helpful. It does not have the fuel supply chain, and so there's some real reliability and resiliency benefits there. It also is variable, and that's not a flaw of clean energy. That's just an inherent characteristic of the technology, right? And so what we need to be able to do is find ways that we can mitigate that or accommodate that characteristic while still having those other benefits. And that's where, again, things like energy storage and, thermal storage and efficiency and demand response can help mitigate that as well. So I feel like I'm a broken record now here, but I think that is a really good solution as we look forward, if it's properly designed and implemented and designed to be that way. Because something like electrification is a great example. Vehicle to grid could provide real resiliency benefits. If everybody goes home and plugs their car in at 5 o'clock or 5:15 and they get home from work, that is going to be a huge resiliency challenge. And so you got to do it right.
Yeah, I want to put just a finer point on the best, and especially kind of like a community scale or a commercial scale one. You're never going to get the financials to work. We've looked at tons of projects where customers come to us and say, hey, I really think we should add a battery because it costs us a lot of money when the power goes out. We've looked at a ton of these financial models. You're never going to justify a project for a battery purely for resiliency purposes. You have to have other revenue streams for that product, playing in capacity markets, doing demand shaving, energy arbitrage, time of use arbitrage, whatever that is. In order to justify putting that battery in, the resiliency becomes the icing on the cake, right? It's an additional benefit that you're getting from it, but you need those other revenue streams to get that resiliency benefit.
Unless you monetize the more humane elements of it, if we start thinking about what the refrigerator and freezer of rotten fruit is and what it means to be cold and to have to move that baby to a different state that isn't there, and those expenses. So there's a whole set of the human experience that isn't monetized in those. So it's just trying to be responsive to your question, sir.
I appreciate that. Unfortunately, we are at time for this panel, so we're going to have to cut it off here. But our panelists will be around, so if you have follow-up questions, please feel free to talk to any of them. Us, in 15 minutes in the main area, we will have our second keynote speaker, and then we'll be wrapping up the summit for the day. But thank you all for coming. Thank you three for speaking to us. And yes.
Thank you, Lauren, for having us.